This video is supposed to be the solution for open book quiz part 2, impulse and momentum, okay? And part 3, which is Newton's law of motions. So part of this objective is to be able to interpret what's going on for the graph, to be able to understand what's going on for the concept behind this. So just go ahead and let's say this is question A. You're looking for the impulse. So impulse during first 5 seconds. So basically, I'm just gonna get the area under the curve. So it will be F times T is equal to area under the curve. But this one just happened to be the triangle, so the area under the curve is 1/2 base times height. So 1/2 times 5 times 10, and actually give me 25 Newton. It's Newton seconds. This is what impulse is. So the impulse is that. So question B, if the object has initial velocity at 2 times 0, so you calculate final velocity, after time 5 seconds. How about 10? I'm just gonna make it 10 seconds. So basically this is the equation you will get. First time is equal to mass Vf minus Vi. First time is area under the curves. But this one, the area is added because you're actually getting the area under the curve of these things. So my area under the curve is actually 75 because we have 50 here plus 25 is 75. The mass is actually 3 kilometers. Vf minus Vi. So I'm just gonna go ahead and, but we know initial velocity, which is equal to 2 meters per second. So what I'm doing right now is I attribute it. 3F minus 6 is equal to 75. 3 final velocity is 75 plus 6, which is 81. So my final velocity is 81 divided by 3. That's my final velocity after 10 seconds. So C, if you want to calculate, we using F equal ma, but I'm solving for the acceleration. So acceleration is equal to force divided by mass. But now we're gonna have to figure out during the first how many seconds. So this one I'm just gonna say 10 seconds. I'm go over here 10 seconds, go up to figure out what force is. My force is 10. My mass is 3. So therefore my acceleration is equal to 10 divided by 3, 3/1/3. That's my acceleration. We apply concept here the same thing. So we don't know what the mass is. So for this one, 3A mass, we don't know what that mass is. So but we use F equal ma. So my mass is equal to that. So we're gonna have to figure out during what time. So we're gonna say that during the time 10 seconds, just to be more precise with everything else. 10 seconds go all the way to the force, which is happen to be 10. So that will be 10 divided by my acceleration is equal to 2. So that would be 5 meter per second square. And that would be my mass. And that's not the unit of mass, isn't it? Kilograms. And that's how we solve for the mass when you're given the information from the graph. So this is how you would do this problem.